Hello everyone, this is SONGHAN Lee from UCL EEE department. The topic that I'm going to discuss today is electrical impedance tomography circuit and system biomedical applications for ultrasound hand gesture recognition. First of all, what is hand gesture recognition? Known as HGR. It aims to recognize a set of specific gestures and usually pre-recorded instead of real-time operation. So let's talk about two categories of the HGR. There are two main types of HGR. One is non-contact, another is contact. Non-contact one uses radar detection to detect hand gesture without touching, so it might be more comfortable. There are also some disadvantages of non-contact HGR. For example, the non-contact HGR requires the radar detection with the radar station. Therefore, the radar station has to be relatively fixed position. Contact HGR. As the name suggests, you have to put a sensor to your skin. Most popular method of this technique is surface electromography, known as SEMG. It relies on estimation of muscle contraction to implement proportional control strategies, which makes it the most commercially successful method up to now. So what's the limitation of SEMG? SEMG is stochastic because a slight change in the tension of muscle can mean a completely different move. Therefore, the signal processing is much more difficult than people expect. After talking about the basic concept of this research, the question is, what's the use of this research, or what type of people are most beneficial from this research? So this research benefits plenty of people, including game player and disabled people. For example, prosthetic control. HGR can be integrated with exoskeletons, then benefits amputee patients. Apart from that, augmented reality and virtual reality also rely on this method. HGR allows players to interact with virtual reality so that the game becomes more immersive.